Now let's talk about the flip-flops. We said that using the latch we can produce the flip-flops. Actually, flip-flops are constructed by the latch and also clock pulse. Now here I want to design the D flip-flop using two D latches and one inverter. Let's investigate this circuit, and I want to show you that what is the meaning of the clock pulse. Here, first of all, we suppose that the CLK is equal to 0, means that we have in the negative level of the clock pulse. So when CLK is equal to 0, from here the CLK will be equal to 0. So this 0 comes here and 1 comes here. Now, the first D latch called as master, the next one called as a slave. Because the enable of the master is 0 and enable of the slave is 1, we can say that master disabled, slave enabled. So what does it mean? It means that because this latch is disabled, it doesn't matter what is the input of the D, because this latch will not work. But because this slave latch works, the D, which is connected to the output of the master D latch, in the output of the master D latch we have the Y comes from to the input of the D latch, and D latch transfer this Y to the output. So it means that our output is equal to Y. What is Y? Y is the previous value of the master D latch. Now we have the rising edge in the clock pulse. It means that CLK get 1. When CLK get 1, here you can see that the enable of the master D latch will 1 and enable of the slave D latch is equal to 0. Now this time the master enabled, slave disabled. So what does it mean? It means that the D from the inputs comes to the input of the D latch and the output will be equal to D. And this D will move to the input of the slave latch. But the output will not be D because the slave latch will be is the disabled. So the output of the slave latch is the previous value of the slave latch, that was Y. So it means that any change cannot affect the Q, and Q is equal to Y. Now again, suppose that we are in the falling edge. Again, CLK is equal to 0. From the previous one, you can see that the input and output of the latch is D and Y. Now, when enable is 0, enable of slave is 1. Again, master disabled, slave enabled. Again, it doesn't matter what is the input of the master D latch, but because the slave D latch is enabled, the D value of the input will move to the output and Y converted to the D. Now we can see that Q is equal to D. What's happening? The flip-flop output changes only when the clock pulse is in the falling edge. So we could design a D-type negative edge triggered flip-flop. It means that the information can be transferred from input to the output when clock pulse is in the falling, in its falling edge or negative edge. Can we have the positive edge triggered D flip-flop? Yes. How? Look at here. This is the another form of the D flip-flop that its edge is positive. How? Look at here. First of all, let's learn that we have to learn this table and also this function. This is the state function table of the D flip-flop, and this is the state equation, which is equal to D. And when D is equal to 0, the QT plus 1 is 0. When D is equal to 1, the QT plus 1 is 1. Now let's investigate this circuit. This is the designing of the D flip-flop using 3 SR latch with the NAND. Now, again, we suppose that CLK is equal to 0. Now, we say that here is equal to 0. These two inputs is equal to 0. Now we know that when one of the input of the NANDs is equal to 0, the output is equal to 1. Now we have, because this one connected to here and this one connected to here, we can say that all of these inputs will be equal to 1. Now D from here comes, and the output of this one will be equal to D prime. This D prime connected to the both of the other NANDs and converted to the D prime. Now D prime 1 will be equal to D. This D comes here. Now we could find all of the inputs and outputs. Now we can see that the S and R does not change, and everything in and S and R will be 1, and this is the meaning of Q does not change, because we said that in the SR latch with the NAND gate, when S and R is equal to 1, the Q does not change. What's happened when CLK, the clock pulse, is in the negative level? The output of the D flip-flop will not change. Now let's suppose that the CLK is in the rising edge and CLK is equal to 1. When CLK is equal to 1, these two inputs will be equal to 1. Now the output will be changed. 1 converted to the D prime and this one converted to the D, because the output is D1 and 1 D prime. Now anyway, this one converted to the D, this one converted to the D prime, because connected to the D prime. So again here will be equal to D prime. And now we said that you can see that the SR latch input here is equal to D and D prime. Because this is the NAND gate, we said that we have to look at to the value of the R, which is equal to D, so the output will be equal to D. What's happening? The D flip-flop transferred the input to the output when clock pulse is in its rising edge. And if we have in the falling edge of the clock pulse, here will be equal to 0, 0. D prime again will be converted to 1 because the input is equal to 0. Also D converted to 1. This D will convert it to 1. This D prime will be converted to 1. So this D prime again will be converted to 1. Similarly, you can see that because the S and R again here is equal to 1, the Q does not change, and we will have the previous value of the Q keeping in the inside of the D flip-flop. You can see that this is the concept of the D flip-flop with the negative edge and positive edge. Here we could design the positive edge using 3 SR latch gates. Now, how we can understand that the flip-flop is the positive edge or negative edge? Again, same as latch, these two type of the symbols are the symbols of the D flip-flops that you can see in the circuits. Now, if you can look at here, this actually a symbol indicator denotes this concept that the flip-flop responds to the edge transition of the clock. And also here, but if we have the bubble here, means that this flip-flop work with the negative edge. When we don't have the bubble here, means that the flip-flop work with the positive edge. And we have to notice to this matter that when we want to analyze the circuits, we have to consider this matter.